Hello and welcome back. We now discuss question number 3 from exercise 6.1. The question says a company manufactures two types of chemicals A and B, right? So we have two chemicals over here, A and B, and each chemical requires two types of raw materials P and Q. So we have the raw materials P and Q over here. The table shows the number of units of P and Q required to manufacture 1 unit of A and 1 unit of B. Okay, so for 1 unit of A you have 3 units of P, 2 units of Q, and for 1 unit of B you have 2 units of P and 5 units of Q. Also they mention the availability. So the raw material P, it's like availability is 120 units and Q's availability is 160 units. Next, the company gets a profit of rupees 350 and rupees 400 by selling 1 unit of A and 1 unit of B. So the profits of A and B have been given as 350 and 400 per unit. Formulate the LPP to maximize the profit. So obviously we'll obtain the profit by selling the two chemicals, but we don't know what would be that profit, and that would be decided by the number of units of A and the number of units of B. So profit is dependent on the quantities of A and B. Okay, so let us assume that as X and Y. So the first step would be, let X be equal to the number of units of chemical A and Y be the number of units of chemical B. Now, as always, X and Y cannot be negative because number of units can't be in negative. They could be 0 but not in negative. So therefore, we have a non-negative constraint. So we could say both X and Y are greater than or equal to 0. Now we bring down this table as it is, chemical versus the raw material. Okay, so we have the chemicals here, and next we have the raw materials over here. So we have the raw materials. Now there are two chemicals. Let us draw the table first. Draw this table over here, draw this line here. Okay, so this is the table out here. Now there are two chemicals A and B. So we have chemical A, quantity is X units. Then we have chemical B, quantity is Y units. Next we have the availability of the raw material. So that would be the next column. The next column would be the availability or the available units. Okay, let me just correct this. So the availability, and the last column would be the inequations. So final column would be the inequations. Alright, so let's proceed with this. We have our table ready. We just need to fill up the values. Now there are two raw materials over here, P and Q. Now A requires 3 units of P and 2 units of Q. So we have 3 and 2. Chemical B requires 2 and 5. So we have 2 units of P, 5 units of Q. The availability is 120, 160. So this is 120 and this is 160. So let's form the inequation. The first one would be for raw material P. Now the total quantity of P required would be, for X units it would be 3X for chemical A, that's 3X, plus for chemical B it will be 2 into Y, that's 2Y, but the total availability is 120. So this total is less than or equal to 120. Now for Y, we'll have 2x units for A and 5y for B. So this is the total quantity of Q required, but we have only 160 units. So that's less than or equal to 160. Now they have also specified the profits. It's 350 and 400. Okay. So let us write down the profit per unit. So the profit per unit in rupees. Okay, the first one is 350 for A and 400 for B. Let's cross check. Yeah, it's 350 and 400. So from here we could obtain the total profit. Okay, let us denote this by Z. The total profit would be, for A it would be 350 into X for X units, plus for Y units of B it would be 400Y. So this is the total profit over here. We just complete this table over here. Okay, so we have set all the conditions and therefore we get the LPP as, so we say the LPP is, now since we are talking of profit, it has to be maximized. So we say maximize profit. Profit is Z. So Z is equal to 350x plus 400y subject to the restrictions. Now these are the two restrictions for P and Q. So the next heading would be subject to. Now the restrictions are 3x plus 2y less than equal to 120. Next, 2x plus 5y less than equal to 160. And lastly, the non-negative constraint, that is x and y both are greater than or equal to 0. So this is the required LPP.